Hi, welcome to Talking Tech. I'm your host, Marcus Yam, and we're here today to talk about something some people may think is just as important as air and water, and that's Wi-Fi. There's a new Wi-Fi on the horizon, and joining me today is Carlos to tell me all about Wi-Fi 7. Carlos, thanks for joining Talking Tech.
Hey, it's my pleasure to be here. Thanks for this opportunity.
So first of all, who are you and what do you do at Intel?
Yeah, so I'm an Intel Fellow and also the CTO of our wireless business in the client computing group. And I've been doing wireless for forever. I remember the days when I was in college in 1997. That's when Wi-Fi and all those wireless technologies were really being born. And to me, wireless is almost indistinguishable from magic. I mean, just imagine data is going across the air. So that's when I really became passionate about the technology, and I really wanted to delve into wireless communication, and I've been doing that ever since. And I'm happy that Intel is really leading in the industry in so many ways when it comes to wireless, and that's my place. That's the place I want to be.
So I want to know everything there is to know about Wi-Fi 7 because I'm excited about new technology. I'm sure we all are. I want to go over, tell me why it's faster. Let's talk about speed. Let's talk about, and everything to do with speed, right? It's more, it could be bandwidth, throughput, latency. Of course, like you said, Wi-Fi has to be reliable. If it doesn't work, nothing works.
Yeah.
And of course, security, right? Keeping your data secure is very important. So let's start off. Tell me how Wi-Fi 7 is faster. Is it purely, and how do we define speed? Is speed bandwidth? Is it faster in bandwidth, faster in latency? How is Wi-Fi 7 faster?
Yeah, so there are a few variables when you look at speed. If you just go back to information theory, the higher the channel bandwidth, the more you can pump on a channel. It's almost like a pipe. The fatter the pipe, the more you can go through the pipe. So in Wi-Fi 7, we essentially doubled the channel bandwidth compared to Wi-Fi 6. So we went from 160 megahertz channels to 320 megahertz channels. So right there, you have double the rate, but we went above and beyond. We also increased what we call the modulation order, how you basically code data that goes over the channel. So we are using a higher modulation order, which we call 4K QAM compared to Wi-Fi 6 that we went up to 1K QAM. So all in all, when you take a typical client that has two antennas, most of your laptops and smartphones that have two antennas, we essentially went from a data rate that was around 2.4, 2.5 gigabits per second in Wi-Fi 6 to about 5.7 gigabits per second in Wi-Fi 7. So
it's a really big jump.
Essentially, over double the data rate. And that translates into latency, just falling up, because the higher speeds, you can get better latencies too. And because Wi-Fi 7 is really going to be making a lot of use of the 6 gigahertz band, and with these higher speeds, we can get down compared to Wi-Fi 6 that we could get, around, 10, 15 millisecond latencies. We can go down to single digit millisecond latencies. As a matter of fact, last year, Intel, we had a public demonstration. We were able to show 1 millisecond latency with Wi-Fi 7. And so it really gets down to those, single digit millisecond latencies that are so important for gamers, for, video conference, for so many applications that need those low latencies.
And those numbers, you're talking about that's added latency on top of the internet connection. So there is latency within a local system as well. That's what you're saying.
Absolutely. And, depending if you're talking to a server on the cloud or, someone on the edge, this is just the latency from one point to the next point, from the router from your client. And there can be other latencies that are added in when you talk about an end-to-end system.
No, that's very interesting. Now, radio waves travel at the speed of light. So all this is latency that you're chasing to get down to the lowest possible latency, down to as close to zero as possible. And I know that, gamers, enthusiasts care about these things because even down to the latency of a device, of a mouse or a keyboard, those clicks translate into an action on screen, or even the latency from the screen, given that feedback. So anything to decrease latency is very important. Is there anything more on speed from Wi-Fi 7?
There is. And I think, this capability that we introduced in Wi-Fi 7 to be able to operate in multiple channels at the same time, in multiple links at the same time, that is how we call it, to operate in 2.4 and 5 and 6, and to have clients and access points to be able to seamlessly operate in multiple channels, that's really powerful. And if you look at just the top speed, the theoretical top speed of Wi-Fi 7, that can go up to close to 40 gigabits per second. Now, if you just compare that with Wi-Fi 6, which we could go up to about 9.6, we are talking about a 4 times increase. Yes, this is a theoretical data rate, but even when you go down to what is practical on a device, you're gonna see much higher speeds with Wi-Fi 7.
So clearly, speed is there. Now, I think there's still the thought of if you want ultimate speed, you got to go wired. So now, where does this place Wi-Fi 7 compared to someone who's still thinking that you got to have that hardwired connection for the best speed? Where does Wi-Fi 7 stack up against that?
If you just look at the pure latency today with Wi-Fi 7, and as I was mentioned before, we can get down to that single-digit latency. If you get an Ethernet, yes, if you have Ethernet connection in your house, you can get to maybe a few hundred of microsecond latency. So one can say that the wireless latency is about 10 times more if you take 100 microseconds to 1 millisecond. But the real question is, does that really have an impact on the user experience? Does it really make a difference? And it's important to note that many times players, they're playing multiplayer games. The latency that you add on that access, on that first hop, compared to that end-to-end latency, it's minuscule because you have to go all the way to a server that is on the cloud. And that in itself can take 100 milliseconds. So the point is, if you use wireless today with Wi-Fi 7, or if you're using Ethernet, it's going to be indistinguishable because the added latency that you get from that cloud server, that's really where going to be the latest is going to be. And so I can say it, and I tell my son, really, I said, look, you can play using your Wi-Fi 7 device because you're going to get as good as a performance, as you're connecting a cable in your house.
You bring up a really good point. The way people think about Wi-Fi and the connection, one way people think about Wi-Fi is synonymous with what you said, is internet. But there is kind of two worlds of Wi-Fi, the way some people think about it. One is Wi-Fi is purely the conduit to get this device to the cloud. But there's also people who want to network in the home, and they have file transfers within the house. They have other devices talking to each other in the house, like some of these IoT devices talking together in the house. How does Wi-Fi 7 change, or how does Wi-Fi 7 affect just the connection going out of the home, where in many cases the bottleneck is on the internet connection itself, the pipe leaving the house? And what about how does Wi-Fi 7 affect people who do networking inside the home?
With Wi-Fi 7, you're going to have better density. You're going to have better reliability and latency, as we talked about, right? And that all helps, especially now when you talk about edge computing, when data is moving closer to the user now. And so the performance of the wireless link is so important for that connection out of the house, because now that the data is moving closer with edge compute, you want to make sure that the wireless does not become your bottleneck. And with Wi-Fi 7, we're really getting that single-digit milliseconds that can deliver that performance that we need for those type of technologies and in use cases that are really moving closer. But you bring up a great point. Wi-Fi was always about connection to the outside world, connection to the internet, connection to the cloud, which that's still the case. But more and more we are using to share content, share files, share images with your friend in your house, or to project to a display. You want to watch wirelessly. With Wi-Fi 7, what we can do better is we can do better manageability now. So what that means is that you can actually have access points, being able to allocate, for example, time, spectrum, and as bandwidth for devices to talk to each other now. So you can have now your device talking to another device, and that can be reserved almost, so that you have better reliability and better quality of your peer-to-peer connection. And that's really important, right? So the clients can then tell the access point, hey, I need some time to talk to another device, and I need that spectrum, and the access point can actually manage that. It does require, of course, access points that have good implementation, but Wi-Fi 7 makes that possible.
So going back to an earlier analogy, you've got more bandwidth, you've got more spectrum, but also you're using that spectrum much more effectively and smarter. So next point, we've talked about speed. Let's talk about reliability. So one is, again, reliability is very important, and so is range. So how does Wi-Fi 7 make strides in range and reliability?
Wi-Fi 7 uses the same spectrum that Wi-Fi 6 used, right? So we're talking about 2.45 gigahertz, and of course, now we have the 6 gigahertz band. It's really important to note that as you go high in frequency, your range gets shorter. So, 2.4 gigahertz, that's why many of IoT devices, those simple devices, they use 2.4 gigahertz because, you can install those devices in the far corner of your house and they still get connected. When you go to 5 gigahertz, you have more bandwidth, but you get a penalty on range. And that penalty, it's about, getting a little bit technical, it's about 6 dB less, which, makes a difference. And so devices that usually use the 5 gigahertz band, we want to make sure that, they typically have an access point closer to them than, if it were 2.4 gigahertz. And then 6 gigahertz, which has additional penalty on range. So the way that we see the market evolving is that what's really important, two things to address reliability and coverage and range. Number one, it's a lot about rate versus range. So it's not just that you want, the greater range, but you also want to be able to have a higher data rate for that same range. So if you were to have a Wi-Fi 4 device and a Wi-Fi 7 device, you want to make sure that not only at that, they both can get to that range, but you want to make sure that the Wi-Fi 7 device has higher data rates at that same range. Mm-hmm. So what we look a lot, what we investigate a lot when you look at a Wi-Fi 7 is it offers better rate at the same range. And so it does this because you can get, you have a technology called OFDMA that offers the ability to get better spectrum efficiency. We have better interference management. So whereas a Wi-Fi 4 device, you can have others jumping and talking at the same time and collisions can happen. Wi-Fi 7 gives you more reservation, more predictability, more scheduling. And the other thing is this, we also see the market evolving that today people have multiple access points in their houses. I mean, just look at
mesh networks,
the mesh systems. And that's great actually. Why? Because these mesh systems basically allow you to always get better data rate. People put one in their living room, one in their home, in their bedrooms, and you're also always getting that close link to the access point, getting better rates, and that's going to give you better range as well. So the market is evolving really to a model where we want to improve the spectrum efficiency, and better spectrum efficiency means we're going to have more access points that are going to offer you better coverage, and we're going to have more scheduled access that's going to give you better reliability. And those two together, are going to give you better interference management, and you're going to have a better coverage around your house.
So just to go back to see if I understand this correctly, that even though 2.4 gigahertz has ability to reach further while maintaining its signal, even though there is a dB penalty going to 5 gigahertz, 6 gigahertz, but because Wi-Fi 7 is more efficient use of those bands, or that band of the 6 gigahertz band, that I think I've seen this in some of the materials, that you can maintain gigabit speeds at greater ranges with Wi-Fi 7 than you can with previous generations because of the reasons you've outlined.
You can absolutely, and now we have better interference management. You have OFDMA that can give you better spectrum efficiency. And that allows you to basically offset some of the physics from going to 2.4 to 5 gigahertz.
And of course, mesh networks help that even further. You're really having the access point literally closer to the devices.
Absolutely.
Okay, well, we have to talk about security, right? Because when you're sending things through the air, it feels like security is even more important because these packets are just flying through the air. How is Wi-Fi 7 more secure?
Let me start answer your question with another question. Did you know that Wi-Fi is used across the entire Pentagon? Wi-Fi is used today in the most secure environments. When properly configured, Wi-Fi is as secure as any other technology. It uses industry standards that are verified by the government that they are the ones that are can offer military grade security. The issue with Wi-Fi is that many people when you think about Wi-Fi and security, they think of their Starbucks. They think of when you go into Starbucks, you have the password that is written on the wall, and that's how they think about Wi-Fi. But it's all about how you configure your network. At Intel, right, we use Wi-Fi to sense the most sensitive data, right? And that just shows that the technology, it is completely secure when properly configured. So you need someone that properly configures the technology. And so with Wi-Fi 7, despite of the fact that it also uses WPA3, which is the same technology that we use in Wi-Fi 6. But we said, look, let's go above and beyond. Not only we already offer military grade security, but we wanted to provide additional security with Wi-Fi 7. So what we did is that now we have something called GCMP 256. Basically, whenever you send data, whenever you encrypt data, with a key. That key that is a secret that is negotiated between you and the infrastructure. The longer that key, the more bits it has, the more secure the data can be transmitted. So we went from 128 bits with the previous technology with now 250 bits encryption on Wi-Fi 7. So with GCMP 256, it offers additional security compared to Wi-Fi 6.
And to be clear, you said this is military grade, government grade. Even the 128-bit has not been cracked. When properly configured, the not being cracked is still widely used, and we don't know of anyone that has been able to crack CCMP 128. And now it's going to 256, which is actually more than a doubling of the complexity of the encryption.
And that's correct. Not only we went there because of additional security, but that also gives us an ability to parallelize the implementation. So as you go to higher data rates, we're talking about 5.76 Gbps per second and can even higher. GCMP offers better implementation so that you can address those higher data rates in a more efficient manner. And
I should clarify my question when I say it's more than double. I'm just talking about the number 128 to 256. It's actually exponentially more difficult when you increase it like that.
Absolutely.
So, Carlos, you've been very close to the standards bodies, the IEEE. Wi-Fi 7, I know, has been in the making for years. And it's very easy for us to get excited about new technology. But we're talking about Wi-Fi 7 today is because this isn't a faraway technology. This is coming quite soon. So when should people start to see Wi-Fi 7 capable devices out there?
Let me start by saying that Intel, we already publicly announced our Wi-Fi 7 devices. So Wi-Fi 7 is here today already. From Intel, we have several designs already in the pipeline. So the technology is becoming available. And the certification, right? Because it's really important. Right? You talked about interoperability earlier. Right? We want to make sure that these devices work well across clients and access points. The beauty of Wi-Fi is that whenever you buy a Wi-Fi device, from your favorite store, when you bring that home, it always gets connected. And, it seems easy, but in the industry, Intel, we spent so much time making sure that devices are going to work well when they get in the field so that, it's hassle-free, easy for the user to get things connected. And so that's why we want to make sure that when we launch our devices, we are always launching to, compliant to certification, because that makes sure that it's going to work with all the other devices that are going to be out there. And the certification for Wi-Fi 7 will be launching in December of this year. Intel has been a part of that certification, throughout. We're going to have some exciting news in December about that as well. And our devices coming to market now, they are in what we call pre-certified, but they will be certified whenever the certification launches in December. And you're going to see more and more devices launch next year.
Of course. Wi-Fi 7 will be baked into many of Intel's future and upcoming products. But for some of those people who just want to be on the bleeding edge and want to get it quickly, there's also a discrete solution that you can just add to a system without waiting for it to be implemented in the platform. Can you tell me a little bit more about the discrete option versus one that's part of the platform?
Yeah, so a discrete solution would have everything that you need from Wi-Fi, from the RF, from the baseband and the MAC, all integrated into a chipset. And that allows us customers and our users to be able to take that discrete solution and use it right away. They can even replace existing chipsets that they have in their own devices to be able to enjoy Wi-Fi 7 immediately. The integrated solution, on the other hand, it's a more cost-effective solution. So what we do is, instead of giving you that larger chipset, we actually integrate part of it with what we call the MAC die. There are two dies. We integrate one die into the SoC. And by integrating that into the SoC, we essentially have a more cost-effective solution and something that we can offer. That's what we call integrated, because then the customer only needs to take a small chipset. We only has the RF and the PHY die. So that's this trade-off between an integrated solution that's more cost-effective and a discrete solution that is available right away, not only for PC platforms, but also for non-PC platforms.
So Wi-Fi 7 clearly has tons of promise. Can you just, to wrap things up, summarize what does Wi-Fi 7 bring to, not only just the home, what do people think of using Wi-Fi at home, but also larger implementations, such as, of course, in the office, businesses use Wi-Fi, airports, cafes, anything like that. What does Wi-Fi 7 bring in those scenarios?
It's a major improvement, because as we are talking about, the data rates that you're going to have with Wi-Fi 7, they're going to be at least double what you can get with Wi-Fi 6. Just imagine, we're going to be able to not only, you're going to not be able to have your video conferencing, your voice call, but now we are talking about augmented reality, virtual reality. The applications that you open up with that type of data rates and that type of low latency, that single-digit millisecond latency, it's going to open up new possibilities for other applications. It's going to allow us to have better manageability and to have those, what we call the device-to-device connectivity, your phone talking to your laptop, and that seamless connectivity between devices. Sharing screen, you can use your tablet as your second screen from your PC to your tablet. So you're going to have so many more applications that are going to be able to make use of that higher data rates, lower latency, and better manageability. So
that's tons of information on Wi-Fi 7. And the best part is sometimes we talk about technology that's far away. I know this has been a long time coming, but Wi-Fi 7 is finally here. And I can't wait to see it all around me. Carlos, thank you so much for talking tech.
Thank you very much. It was great to be here talking to you.